Okay, so solving. Anytime we solve, that means we're trying to get x by itself. Okay? But before we do that, let's do a little bit of something we're going to see today a lot. You're going to see a lot of this today. Squaring square roots. Okay? Okay, let's talk about squared, the 2, the exponent. What does that mean when we have squared? Times itself, right? So let me rewrite it. So really what this means is square root of 2 times the square root of 2, right? And then last week, we learned, can we multiply these two? Because they're both roots, right? So you get the square root of 4. What is the square root of 4? 2. So the finished answer is 2. Okay. Let's look at B. Same question, just instead of 2, we have a 9. So that means the square root of 9 times the square root of 9. We can multiply those because they both have square roots like we learned last week. 81 is on my list because the square root of 81 is 9. So before we get to the other ones, is there a shortcut instead of having to do all those middle steps? Is there a shortcut anytime I square a square root for what my answer is going to be? It's always squared. So what's a shortcut? Yeah, whatever's there is going to be, right? The answer was 2. The answer was 9, right? Why does that happen? Well, because it's their opposites. Squaring and square root are opposites. It's like if I took 2 steps forward and then did the opposite 2 steps back. I'm back where I started, right? It's the same thing. So C, what do you think the answer is going to be for C? There you go. Regular old X. What do you think the answer is going to be for D? X plus 5. Okay. So anytime you square a square root, it just goes away. Disappears. That's how you get it to disappear. Okay. We're going to see a lot of those today. In fact, on the next problem, we're going to see those. All right. So today, how do we solve? 4 main steps. Get the radical by itself. So if it has a radical, get it by itself. Okay. On one side of the equal sign. How do we get rid of it? Square it, right? And then solve for your solutions, and then check to see if we have this thing called, we've never talked about this. I don't know if we've seen this word, extraneous solutions. Extraneous solutions are solutions that don't work. They're answers. You get the answer. You did everything right. I got my answer, but for some reason it doesn't work. Why doesn't it work? I'll show you why. I'll show you why today. Okay? Okay, so number 2. First thing we're going to do since we're solving, anytime we're solving, we're going to draw a line down the equal sign to show the left side of the equal sign and the right side of the equal sign. Here is the root and everything in it. Is there anything in that root? Is there anything on the left side that's not in the root? Yeah, -4, right? -4. So how do I get that away from the root? Add it. Do the opposite. Add it, right? We've done that before. So I write what I have. Okay, I still have a root. And it's got x plus 10 inside of it. Is there anything else on the left side with that? Is there anything in front or after? No, right? It's by itself. Okay, that's step 1. Step 2, get rid of the root. How did we get rid of the root earlier? Squaring it, right? That's what we're going to do. But because there's an equal sign, whatever I do to one side, I have to do to the other. It's balanced. It has to be a balanced. If I do it to one side, I got to do it to the other. Well, we talked about this. Anytime I square a square root, what's the answer going to be when I square a square root? X plus 10. Square 3, what do I get? 9. Simplify and solve. Well, get x by itself. Subtract 10 from both sides. Subtract 10 from both sides. I get -1 as my answer. Okay. So I told you, how do we know if something's extraneous? Because they're going to say leave out. We always leave out extraneous. It's an answer that doesn't work. So how do we check to see if it works or not? Well, we plug it back into the equation. So if I were to plug in -1 in here, I'd get -1 plus 10, which is 9. What's the square root of 9? Well, I get a negative plus 10, right? So it becomes positive, right? You're right. I can't have a negative in there. That's a no-no because that would be imaginary. But when I add it together, I get 9, right? What's the square root of 9? 3. 3 minus 4? Okay, this one works. They won't always work. About 10, 20% of the time, you'll get an answer and it won't work. It won't make the answer we want. Then we call it extraneous. Okay? So it won't happen a lot, but it will happen enough where you want to check. So that answer is okay. It worked. Sometimes they won't. They're called extraneous solutions. Okay.
How do you answer it if it's extraneous?
Good answer. So if it's on Delta Math, you wouldn't put that answer. So sometimes you'll get 2 answers. On the back, we'll get 2 answers. Sometimes one of them won't work. If we only have one answer and it doesn't work, on Delta Math, you just leave it empty box. And that's it. Most of the time we get a situation where we get extraneous solutions, there'll be 2 answers. One of them will work, one of them won't work. And I'll show you on the other side. There are some problems. I do have some problems on here where that happens. Okay, so let's flip to the inside now. Number 3. Solve. Okay, so my root is right here, and I have 6x plus 7 inside of it. Not really worried about the stuff inside the root right now. All I need to know is there anything with the root? No, it's just 6x plus 7 in the root. Okay, so I can skip step 1. I can skip it because I don't need to do it. So step 2, get rid of the root. Okay, so square this side. Square this side. I got to do it to both. When I square a square root, it just, whatever was in there before, just is the same. It's 6x plus 7. Now the other side, it's not just 2, it's x plus 2 squared. We've actually done this before. It's x plus 2 squared. So in other words, it's x plus 2 times x plus 2. That's what that means, right? How do we simplify those? We've done this before. We did it last semester. Starts with a B. Box. There you go. Okay. I have an x plus 2 and an x plus 2. So you multiply. X times x makes x to the second power. 2 times x makes 2x. 2 times x makes 2x. Positive 4. Combine like terms. I can combine two of the sections of the box because they're both like terms. So I get x squared plus 4x plus 4. Step 2 done. No more root. No more radical sign. Step 3, simplify and solve. Okay, so this one has a squared, right? So when we have squared and we need to solve it, or you need to do what we did last semester. It either needs to become a trinomial or a binomial. That's why I left the steps from last semester up on the board, because we know we'd see them again. So first step for either is set them equal to 0. Set them equal to 0 because, yep. So 6x, I'm going to subtract 6x from both sides. So I subtract it from 4x. So it makes a negative 2x. Close. Now I got to get rid of 7. Subtract 7 from both sides. It turns out this guy is a trinomial. It's got 3 parts. Okay. So that was step 1, set it equal to 0. Step 2, GCF. No, it doesn't look like it has a GCF. Step 3, ABC. B is going to be negative 2. C is going to be negative 3. We're looking for the two numbers that multiplies to be negative 3 and adds to be negative 2. So there's only two ways you can make negative 3. Negative 3 times 1 and negative 1 times 3. Well, to make negative 2, that means the negative 3 is going to have to be positive or negative. We're going to use the box again, but we're going to use it differently this time. So remember, x squared goes in the first section of the box. Negative 3 goes in the last section of the box. And then the two guys I came up with go in the 2. So negative 3x and positive 1x.
You said it doesn't matter which box.
No. Yeah, these two guys here don't matter. The negative 3x and the 1x, those can be switched. Yeah. As long as these two, x squared and minus 3, are there, you're good. So x times x minus 3, positive 1. Okay. So how now? I have the factored terms, x minus 3 and x plus 1. How do I get my answers? What's the last step to solve? Set them equal to 0. There you go. Yep. Set them equal to 0, just like we did last semester. You're going to get two answers. And you're done. Those are the two answers I got, -1 and +3. But I have to check to see if they're extraneous. I have to see if they both work or if one of them doesn't. How do I do that? You plug it in. You can do this part in your head, or you can do it in your calculator, right? You can use the calculator to do this, or you can do it in your head. So 3. So if I plug in 3 up here, so it's 6 times 3, 18. Plus 7 is 25. The square root of 25 is 5. Plug it into the other side. 3 plus 2 is 5. They both equal 5. So 3 is a good answer. Plug in -1 now. -1 times 6 is -6. Plus 7 is +1. The square root of +1, +1. Okay? Plug it into the other side. -1 plus 2, +1. So they both equal +1. So in this case, we'd have two boxes. +3, -1. Okay? All right, so now let's try. The next one's very similar. The next one is very similar to the one we just saw. Okay, so let me draw my blue line. Got my root there. Okay, so the only thing on the left side is the root. Good. Step 1 is good. Step 2, square. So we get 11 minus x equals, because that side works out nicely. The other side, though, is a binomial. So I have to set up a multiplication box for that. Combine like terms. Move it back. I get x squared, combine like terms, minus 10x plus 25. That's step 2. Step 3, okay, it's got a squared. So now I got to go to my, now I got to either make it a binomial or a trinomial. If it didn't have a squared, it would be like the first one we did, right? Number 2, the example number 2 on the front. But because it has a squared, that means it's either going to be a binomial or a trinomial. So I got to set it equal to 0 now, okay? So I have 1x, -1x here. So the opposite would be add 1x to both sides. Okay. Positive 11, the opposite is negative 11, so I'm going to subtract 11 from both sides here. Trinomial, turned out to be a trinomial. It's already set equal to 0. Doesn't look like there's a GCF. ABC. Okay. So 14 goes on top. Negative 9 goes on the bottom. So the two numbers that multiply to be 14, positive 14, but add up to be negative 9. It's going to have to be negatives because to add up to be negative 9, negative 7, negative 2. Oops. Negative 7x, negative 2x. Minus 7, minus 2. Last step, or sorry, still on step 3, but we have to solve, right? So we're going to set each of these guys equal to 0. So I get two answers. Positive 7 and positive 2. I'll give you a hint. With step 4, one of them will not work. One of them will not work. How do you know which one won't work? Well, you got to plug it back in. Okay? So I'm going to plug my answers in here and see if they both equal the same thing. So let's try positive 7 first. Positive 7. 11 minus 7 is 4. What's the square root of 4? 2. Okay. 7 minus 5, is that equal to 2? That one works. So 7 works. Okay, 7 gets a check. 2 now. 11 minus 2. 9. What's the square root of 9? 3. 2 minus 5, does that equal 3? Negative 3. It equals the opposite. It equals negative. It's not the same. A positive and negative aren't the same. Positive means here's money. Negative means you owe me money. That's totally different. So on Delta Math, I would only put one answer, positive 7. If you put both answers, it'll say you're wrong. It'll say you're wrong, even though you did everything right. We did everything right. But because positive 2 is what we call extraneous, it's an answer that doesn't work. It just doesn't work. Unless they ask for it. Sometimes they'll say, give me extraneous solution. Which one's extraneous solution? Then you would say. But most of the time, they'll say only the ones that are extraneous. Okay? Like I said, this guy is extraneous. Extraneous solution. Okay. Okay, number 5. Okay, so number 5 is a little different. Look at number 5 right now. What is the biggest thing that stands out to you that's different? It's got a root, so it's not like it doesn't have a square root. It does have a root. There's 2 of them, right? I haven't seen one with 2. All the other examples only had 1 root. The biggest thing that's different about this one is that it has 2 roots. It's got one over here and one over there. So if this happens, what in the world do I do? This is what you're going to do. I'm going to show you. Can we isolate on one side? Well, if I have them on both sides, I can't really isolate them, right? I can't really. Okay. So we're going to skip step 1. We'll come back to it. We'll come back to it later, but we're going to skip it for right now. So we'll go right to step 2. Step 2, get rid of the roots. Square them. Okay. We'll come back to step 1. We eventually do step 1, but we're going to do it later. Okay. The right side makes x minus 10. Problem with the left side, though. It looks like it would make x minus 2. Problem is the minus 2 isn't under the root. So that trick won't work because the minus 2 is not under the root. So if that doesn't work, what do we have to do? We have to do what we did earlier. We have to do a box. We have to do a multiplication box. Because minus 2, negative 2 is not inside the root. If it was, it would be easy, but it's not. Okay. We did this before. You've actually seen this problem today. What's the square root of x times the square root of x? X square root of x to the second power, right? That's the question I'm asking you. What is it times itself? Just x. Just x. Where am I at? There we go. Okay. Can I multiply negative 2 times x? No, like last week, I can't do that because negative 2 is not inside. So what do? I put negative 2 and then root x. Same thing for the next one. And then the last one, negative 2 times negative 2 makes positive 4. Right what I have. I got an x. I got a negative 2 root x. I got another negative 2 root x. And I have a positive 4. Well, I got some like terms here. Just like last week, these guys are like terms. They both have the same root. What do I get when I combine them? Negative 4. Yeah, negative 4 square root of x. Remember, when we're adding or subtracting roots, the stuff on the inside, the radicand doesn't change. It's just the stuff on the outside. So now, here we go. I'm right here. How many roots do I have? How many radical signs do I have? Now, many radical signs do I have? Just one, right? Now I can go back to step one. Now I can do step one because I only have one. If you only have one, you can get it by itself. So now what I'm going to do is I'm going to get that by itself. So I'm going to subtract 1x from both sides. There's no squareds. I don't have any squareds, so I'm going to worry about that. So it's not going to be a binomial or a trinomial. So 1x minus 1x becomes 0. Okay, so I'm going to subtract 4 from both sides. Okay. So the only thing that's not inside the root is that negative 4. How do I get rid of the negative 4? Add, subtract, multiply, or divide. Divide, yeah. Because the negative 4 and the root are stuck together. There's no plus or minus inside or in between. So that means I divide, do the opposite. The opposite will be division. Negative divided by a negative makes a positive over a positive, so you can reduce that to 7 over 2 because you can divide them both by negative 2. The root is by itself. How do I get rid of it? Square it. Square both sides. So we get x equals, how do we square a fraction? Easy. Square the top, square the bottom. So if I square the top, I get 7 times 7, 49. Square the bottom, I get 2 times 2, which is 4. I don't think you can reduce that. 4 doesn't go into 49 immediately. It's like 12 point something. You're done. You are done. Okay. Okay. On page 25, I'm going to give you one more problem because we got some time. I want to show you another problem like that. I want to give you another example like this so that if you have it on your quiz, you have another example in your notes. So I want to give you one more type of problem like this. So if you have room on here, you can do it. Like if you have, like I have room down here. If you don't have room, just do it on page 25. Okay, same directions. It'll be the same directions. Try it on your own. I'm going to do it with you guys, but I want you to try it on your own. Okay, and then if you get stuck, then wait for me. You can pass out the tape while we're waiting. Okay. So it's solve. So we draw the blue line. Well, I have radicals on both sides. So I can't do step one. Step one is not possible because they're on both sides. So I go straight to step two. So on the right side, it's x minus 4. On the left side, it's unfortunately I can't do it as easy because the -8 is not underneath. -8 is not underneath the radical. So I got to do a multiplication box. Square root of x times the square root of x makes the square root of x squared, which is just x. -8x, -8x, positive 64. I got roots here. They're both like terms, so I can combine like terms here. When we're adding or subtracting, remember we only add the numbers in front. So -16 square root of x. Well, now I only have the root on one side. It's only on the left side. It disappeared from the right side. So I'm going to get the root by itself. So I'm going to subtract 1x from both sides. 1x, take away 1x, makes 0 on both sides. Positive 64, I need to change that to negative 64. Negative 68. Divide by negative 16. This one I can reduce. I know I can divide, I don't think I could, 4, I think I could divide it by 4. Let's see. Negative 68 divided by negative 4, 17. So divide them both by negative 4. There you go. Divide them both by negative 4. You get 17 over 4. Very last step, square them. (17 times 17 is 289. 4 times 4 is 16. I don't believe that will be able to be reduced. I can check, but I don't think they share anything that can be reduced. Not 2, not 4. I don't believe 8. You know? Okay. Okay, so tape that into page 25, and tomorrow we'll do some more practice.